Hello, hello, robot fans. Welcome back to my shop. Don't mind the hair, having a rare blonde moment. Let me know what you think. Drop a comment below. Just kidding, I only care about physics. So let's get into it. HiJinx versus Captain Shrederator and the consequences of physics. Spin to win. Spoiler alert, if you haven't seen HiJinx versus Captain Shrederator, go catch up. I'll wait. Okay, moving on. It's been a while since we fought a big horizontal spinner, and in terms of weapon to body weight ratio, Captain Shrederator has one of the heaviest weapons in the entire series, at 120 pounds per shell. For comparison, the heaviest weapon bar in the HiJinx lineup comes in at 71 pounds, and, not by coincidence, that is the weapon bar we chose to use in this fight. Captain Shrederator is also one of the most senior teams at BattleBots, having been in every season of the reboot and other large international competitions as well. So we have a lot of respect for our elders, Mr. Neve, Brian, Dad. I'm gonna call you Dad because your kids are my age. No one will misinterpret that joke. His kids are cool though, we sit at the same table at BattleBots Thanksgiving. In preparing for this fight, having seen Captain Shrederator on the TV for years, we had a notion that if we could break their weapon and keep ourselves spinning, we could outlast them, and the day would be ours. Of course, no plan survives first contact with reality. Historically, in Season 5 and 6, the weapon had been the most reliable system on HiJinx, like, it was unstoppable. And the core weapon stack is exceptionally strong, even among the robots in the series. The stack is tied into the frame to distribute load from big hits, and the thinnest portion of our weapon shaft is 2-inch thick 4140 steel. Later in the season, we'll switch that out to our new 17.4 pH weapon shafts, beautifully machined by our sponsor, P3D Creations. And now, if you've been following for any amount of time, you'll know that it took a lot of effort and some big money to get those 17.4 pH weapon shafts. So you may be wondering why we didn't have one installed for this fight. Okay, listen, sweetie, a lot of things went wrong in the last few weeks of the build. Stay tuned and I will dish all them dirty deets. If you listen to the Behind the Bots podcast, you'll hear me talk about some of the VESC motor controller issues that we had and many other teams had as well. And I also make a cringy comparison about the energy of impact. I don't always nail it in interviews, but I do try. Cringe. Speaking of energy of impact, if we have two beefy horizontal spinners about to throw down, how can we tell how much energy is stored in the spinning weapon before impact? Let's do math about it. At the risk of turning this into a math lesson, which the jocks have informed me is not cool, thank you, Nick, I'm going to write some equations on the board. First, we have the basics of the moment of inertia. Inertia equals angular momentum divided by angular velocity. Easy start. Next, for kinetic energy, there's a linear equation that's not really 4S. Ke equals 1/2 mv squared. Kinetic energy equals 1/2 mass times velocity squared. What we want is angular because we're moving an object around a shaft. So for angular, 1/2 inertia times angular velocity squared. Stay with me, folks. The next one has details. 1, we have to model the shape of the HiJinx weapon bar. So the closest basic shape is a rectangle spinning on a center axis. There's a whole chart of these in physics. We stand on the shoulders of giants. Feel free to look these up. You can use them to model a lot of different objects. So here we have the source. And now we kind of need to convert from freedom units to metric because I'm going to be frank with you, it's easier to do this in base 10, and so we're going to use kilograms and meters per second instead of inches or feet or cheeseburgers per mile. USA! If the mass has units of kilograms and the velocity of meters per second, the kinetic energy has units of kilogram meters squared per second squared. Okay, so let's do some HiJinx math. So the HiJinx extra stout bar has a mass of 71 pounds, which is about 32.2 kilograms. I'm going to round here. You'll have to live with it. The length is 39 inches, or 0.99 meter. The width is about 5.75, and again, I'm rounding here. That's the width at the end, 0.146 of a meter. And our velocity, 2 pi times the frequency in hertz. It's so easy, right? Okay, so this is the source of the numbers. So then we just take our numbers and plug them into our equation. I had to do that off camera because it took a minute. Basically, when you plug all of your values into the equation, this is the number that you get. And this equates to 41-ish kilojoules. Kilojoule. Physics, baby. Just drop that right on the ground. Dropping stuff clumsy. Put all the math on top of the welder. In a sense, math is easy if you know the equation, which you can find online, and you know the variables, which you can find in your model. And hey look, if you don't know a formula, just start with F equals ma and then make substitutions until you get there. Also, you can ask Paloma to help you with your math homework. She's really good at it. But Jen, I hear you say, I don't have all day to doodle on a whiteboard. I need to build a heckin' robot right now. Well, lucky for you, HiJinx is sponsored by Autodesk, and Autodesk has tools for this. So on our team, we use Inventor and Fusion 360 to design, model, even manufacture basically everything on the robot. So for example, if we take Orion's extra stout bar as a solid model, we can estimate its mass and its moment of inertia. We can use simulation as a huge time saver for design and manufacture, and Autodesk has this feature nailed. Okay, so we know optimally, HiJinx can deliver a massive hit, over 40 kilojoules of smashing action, and it's worth noting that Captain Shrederator has a larger, or at least heavier, weapon, with potentially higher kinetic energy to deliver on impact. So to contextualize the energy of things, Orion put together a handy spreadsheet. And whenever someone suggests putting a gun on a BattleBot, just remind them that the energy in a bullet is concentrated to a very fine point that will do serious damage to soft tissue, but would not have a meaningful impact on a robot that is covered in AR-400 armor. The kinetic energy in a HiJinx hit is roughly the equivalent of, like, a Ford Focus going directly into a wall at 15 miles an hour. Like, things are gonna crumble. And so, yeah, we decided to go weapon on weapon. YOLO. Are you not entertained? Y'all know you wanted to see that, don't front. So what happened when we went weapon on weapon? Well, in short, we broke each other. HiJinx did massive damage to Captain Shrederator, more damage than Tombstone did, according to Team Shrederator. But our weapon motor also took some damage. Now, you're a true fan, you've been watching for a while, and you know that HiJinx runs a pair of 8038 motors on a gear drive for our weapon system. So it should be sus when I say motor. As in singular. Right, well, what we didn't know until after our third fight was the cause, the source of the gremlins in the weapon motor controllers, which means for this fight and the Ripperoni fight, we had to go in at half power. One motor. Sad. Very sad. Honestly, this is a terrible feeling. I will never forfeit a match, but going into a fight knowing that one system is limping is awful. We aimed to come correct every time, but we could not push the correct and identical settings to our ESCs, and they were fighting each other. I'm gonna talk about that one in the next video, because I'm not done talking about this fight, so. But we can run on one motor controller. It's not optimal, but it does work, and Rotator made the same choice when their motor controllers were having the same issue. This got us into the arena, and once the weapon is at full speed, it doesn't matter whether you have one motor or two. The potential energy is in the bar, not the motor. Hence, we use the tail defensively to get spin-up time before going in for that big hit. So then the next question is, what killed the motor? And the answer is an absurdly large vertical load. Whoa. Hang on a second, Math Bay. We have two horizontal spinners going full ham at each other. What's this about a vertical load? Well, dear reader, we've known from the start that our large horizontal hits also have a twisting force. And if you think about the bar being on the end of the weapon shaft, the end of the axle, you can kind of visualize how that twisting would happen. That's why there are not one or two, but three plates on the bottom of HiJinx on the chassis to act as a leaf spring and transfer the force through the entire frame instead of letting the force concentrate about the weapon stack. But the magnitude of that twisting vertical force increased with the geometry of the extra stout bar series, because that chamfer on the end of the bar wants to slide into or under the opponent, which means it's being pushed down, and that vertical load transfers into the motors. Physics! So we thought this was fine until we found out that it wasn't. The motor's stator moved internally. Hang on. Poor little shifty stator. The motor's stator moved internally and it was limping after that. The windings were making contact. That's bad. Hang on, I have a solution for this. Actually, Copperhead had a solution for this. This is a gift from our friends on Copperhead. Thanks, Luke. They run the same weapon motors, and they decided to embeefin the motor core with this custom bit of hardened steel. Up until now, we've been battle hardening our motors in the old-fashioned way, but this is kind of next level. With this gift, we were able to reverse engineer a motor core, and I acquired brand new, not damaged stators from New Motor based here in California. So moving forward, we won't have that failure anymore. Because we want the big hits, and I know you want the big hits. I know you do. So yeah, it sucks to lose, but the entire game is figuring out how to suck less. Alright. Okay, let's talk about armor. I need gloves again, the tail's really sharp. Is it time to replace this? Yeah. Haha! Everything on the robot's big and heavy. You see? Jennifer scale. So what we have here is the tail. The tail is primarily a stabilizer, but it can also be used as a defensive object. It is fully capable of acting as a fork when needed, and when fighting a big horizontal spinner like Captain Shrederator or Bloodsport, for example, what we want to do is avoid taking hits during our spin-up time, preferably hit them before they hit us. So, for example, in the fight with Bloodsport, we had a less advanced version of this tail, and we had the long bar equipped so that we could hit them before they hit us. The long bar being our iconic 48-inch bar. The only horizontal spinner with more reach, when they are at the event, is Ice Wave. Love you, Ice Wave, hope you come back. One of the frustrating things about having a candy-colored robot is that sometimes the fake-out works a little too well. Other competitors are rarely surprised by the power in our hits these days, but it can be difficult to see through the TV. So, for example, in the Bloodsport fight, which I thought was a great fight for us, even though we lost, the announcers called every hit for Bloodsport, even though we had better reach, and we were hitting them before they could hit us. In fairness to Chris and Kenny, they can't see the damage that's accumulating inside the robots, so I want to give a shout out and a thank you to Team Bloodsport for showing us the damage post-fight. HiJinx hit their billet chassis so hard that we pinched in one of their tires and one of their batteries, and they had to retire the chassis after that fight. So thank you, folks. You were really great sports about it. Bloodsport, good sports. Flash forward. The tails we had in Season 5 were okay. We were experimenting with articulated wedgelets that attached to the end of the tail and could move freely, but upon review of the mere 30 seconds we were in the arena with Uppercut, we observed that the articulated wedge didn't always do its job of laying flat on the floor. In fact, in the Uppercut fight, it kind of flopped up over their plow, which allowed them to slide in and hit the bottom of our weapon bar, which then sent us both flying across the arena, and we got the short stick on our landing position. Envelope slot. Bummer. Those wedgelets had to go. I will show you one of the new vertical tails in the next video about Ripperoni. Anyway, back to Shrederator. Being one of the heaviest hitters on the horizontal axis, we equipped our horizontal tail. I will have clever names one day. Today is not that day. This tail was originally given clearance on the underside for a flamethrower, but we've basically decided to drop the flamethrower for a while and just add more armor. You might call that an uncharacteristically conservative design choice, but we sometimes fight conservative robots. As you can see, I have closed off the flame hole with thick steel. This reinforces the tail to prevent a split like what Sawblaze was able to achieve in Season 6. And then, added some speed holes in the long flat. This allows us to save weight. Also allows me to use my favorite tool, which is the plasma cutter. I have many favorite tools. What's special about the horizontal tail over the vertical tail is the shape of the sweep at the end. This is ideally designed to help horizontal hitters skip up over the tail. As you can imagine, skipping up and coming back over. Aha! And then let us stay under our opponent, do some damage, control the fight. The sweep here is thicker than the rest of the tail because, well, as you can see, it gets hit sometimes. So 1/4 inch AR400 plate, and getting adequate weld penetration on these plates in my cold shop, now located by the ocean, I use preheating to get the steel up to temp, and then quickly fixture the pieces in place and go full send with the welder. Got the beans turned all the way up. This shape, the way it sits flat on the floor once installed, this has to be cut into the steel while the tail is on the robot. As a natural consequence, the newest tail will give HiJinx a slight forward tilt, and then every time we go into the arena, we have to recut this wedge, which changes the tilt slightly back each time, and eventually there isn't enough material to keep sharpening it, at which point we would retire the tail. You know, assuming nothing else had gone wrong first. And this year, the person who took on the difficult manual labor job requiring muscle and precision was our new teammate, Gino Esposito. Seen here at regular speed, Gino had been on Team Shrederator the prior year. Gino is a travel nurse and decided to shift from a contract in Florida to one in California because of the weather. Gorgeous here. Every time Gino does something dangerous in the shop, I remind him he's the only one who can repair humans. Gino, you are the healer in this party, please don't die. So, back to the fight. Did the tail do what it was designed to do? Yes, it sure did. But did it do that job perfectly? Not exactly. Yeah. This damage at the interface to the chassis contributed to HiJinx tilting, and while the weapon was struggling to fire back up, we wound up high-centered, like things were on, we just couldn't move. Frustrating. The coup de grace was, of course, that a drive chain had snapped. It's likely that it snapped from the force of the big hit translating through the robot, but it is possible, I am ashamed to say, that the chain gave up because it had already been in multiple fights and needed to be replaced. You can bet moving forward, chain replacement is going on the post-fight checklist. Initially, after this fight, I was just gonna trim that steel off and repair it because it's kind of fine, but we are considering a new design for the horizontal spinners. This one's gonna go up on eBay. And look, it's steel, so it's heavy. You're gonna have to pay for shipping. Sorry. Not sorry. I'll sign it. It's got battle damage. Please bid generously. All proceeds go to help HiJinx suck less. Meanwhile, to make it easier for me to manufacture more of these tails in the future, because they are a bit fiddly and they do have angles, I sent some prints to our sponsor, Send Cut Send, and received laser cut steel pieces to make a nice fixture. It's gonna make my job nice. Also going up on eBay, we've got some pieces. I got this hubcap from our big dill fight, and this is also gonna go up on eBay. I've got some small pieces that we'll put up on Etsy, and I'll put links in later. Speaking of helping HiJinx suck less, feel free to buy some merchandise. I got these new sweatshirts, team gear, poker chips, bits of broken robot, all that. I want to say thank you again to our sponsors, Autodesk, for providing us the software that we need to build the robot, Van Beber Brothers Incorporated in Petaluma, California for providing steel, P3D Creations in Florida for excellent machining, Montana Cans for making us look so good, IMS in Rosedale, California for another machining job, Send Cut Send for giving us the very best laser cut materials, Jen's Ace for providing our batteries. I want to thank the fans for sticking with us. I know we're having a rough patch right now, but every time you write to me that your kid loves the robot, or that you were inspired by the robot, or that you want to get into engineering because of this robot, like every time I hear that, it warms my heart. So thank you very much. You keep it 100. I want to make sure I thank all of our teammates, especially Paloma for actually checking the math, Orion for doing a bunch of work behind the scenes, and Gino for joining us. I hope you're still having fun, bro. All right, we'll see you next time when we talk about Ripperoni. Rip. Okay, bye!